Okay, now that we have the parts 3D printed, I'm going to go into the type of lamp flashers that I decided to use on my model. Well, you can do anything you want. I'm just providing a very low-cost option for this. Basically, I have two of the bright LED units there. We're going to wire up the third one so you can understand what's going on. I did a lot of shopping at the dollar store just to keep this on the low, but found a US device that had a USB cable on it, so I got that. So I could plug it into my computer, my power bank, or a 5-volt USB power supply, whatever. You don't have to run yours on 5 volts. You can change a resistor I'm going to show you here in a minute, and you can run it on 12 to 15 volts, whatever you want. So when I was in the dollar store, besides finding a USB cable that I wanted, I was looking at all their different little flashlight things, and I saw these, and I went, for the price, I have two possibilities that it might work. There's a front bright LED, and I was thinking that might be the best one, and it is. Or I have this larger cob LED, which is quite a bit brighter. It's supposed to put out up to 100 lumens. Well, that would fit as well. So I picked up, I think we're going to need more room. Anyway, we're going to tear this apart. I'm going to show you how to wire this up. Before I get to that, since I'm going to have to move the camera, what I'm using to make the lamps flash, and it's inside this bag, is a little 555 timer that you can buy for less than $1 online, or you can pay as much as you want because there's sellers that will sell them to you for as much as you're willing to pay. There we go. Focus on that. As you can see, you have ground, you have output, and you V plus in. You have a rate control. The only thing we have to modify is this is the timing capacitor. So on the back side, I solder on some, come on focus, solder on some more leads, and I replace, well, I don't even take that cap out, I just leave it there. I solder in a 4.7 UF capacitor right across there. In my case, my capacitors are ceramic, so it doesn't make any difference on the polarity, but if you're using an electrolytic, you'll want to verify with your ohm meter that this side of the cap is in fact ground. And if that's the case, then you'd have the negative side of your capacitor here and your positive side there. So that's the only change I make to get the flash rate slower. And this will allow you to adjust it from very slow to very quick. We're going to get into that more. It's just that I'm going to have to move the camera, and I didn't want to move it twice. So let's move this here. And this is just one example. You can find them on eBay, you can find them on Amazon, but here's one example of the same device that I found. This one was on AliExpress. Free shipping, 85 cents. You know, why not? Pick up a bunch of them, use them for other projects. Okay, we need to move things, I think, over to this surface here. Maybe somewhere like that. So we can get this here, get that. I don't really need you there. And the soldering gun is getting warm. It's kind of in the way at the moment because we need to tear down this light like I talked about. It just seemed to offer so many possibilities for the $1.25 that I figured, why not? It's held together with screws, so we're going to take out a bunch of screws, and I'm going to save these screws because a lot of times these come handy in other projects that I'm doing. In fact, if you needed battery box components, you might want to save those also. Lots of screws. This thing was designed to run on this lamp 3 AA batteries, which would be 4.5 volts. They're only using a 1 ohm current resistor, limiting resistor, which pushes the LEDs super hard. That's how they were getting all that brightness out of it. I'm not going to push my LEDs that hard. I don't need that much brightness, and I don't want them overheating and going bad on me. That one. Like that. Need some wire cutters. Get that out of there. Get that out of there. So like say if you were doing some other project and you needed a battery box or something, you've got the components there, or you could just save and use that whole thing as a battery box. The large cob one I'm not going to use for this project. I'm going to leave the wires attached to this little round one that was in there. There's nothing special about this. You can find anything that looks like it's going to be a bright flashlight and just use that. I just saw these and thought, this might work out really well. Get that over there. All these little screws, which I'll probably lose. Let's get those out of the way. Okay. So here's the LED unit itself. You notice they mounted it on an aluminum heatsink because they're pushing it so hard. I'm not going to push mine hard. I'm going to not use the 1 ohm resistor they had, and I'm going to use just something I found on my junk drawer. This is a 39 ohm resistor. Big difference, right? Instead of drawing like 200 milliamps into that little thing, we're going to drop it way back. I'm going to put that resistor, I think, onto this timer circuit to keep it locked down. This is the negative pin. I'm going to attach a wire to that in just a second. And there's the positive. And which way do I want to bend this? I'm going to bend this one back this way. That's the output pin. A 555 chip can source as a positive source 200 milliamps max. So we're going to be well below that. We'll be okay. And let's put that around like that. So what do I do first? I think first I got to try to get that capacitor on the back here like we just talked about. See, without it, this is basically running up in the audio range. You wouldn't even see the light flickering. It'd be going so fast. So first thing I'm going to try to do is get some fresh solder on there. The tip is really dirty. I don't have anything here to wipe it off with. This is the little ceramic capacitor I'm going to use. You could use electrolytic, you could use a tantalum, you could use whatever you want. This is just what I happen to have laying around, and it's supposed to be a 4.7 UF, so I've even done it with a 10 UF. You just end up turning the trim pot to the faster position, because with a 10 UF on there, it's going to be a real slow blink rate. Of course, maybe you want a real slow blink rate, and that would be fine. Alright, I think it's on there. We'll find out soon enough. I'm going to tin up these leads that we bent over, or I bent over. I don't know why the autofocus isn't working as well as it normally does today. Makes it easier to put the wires on later if you've got this stuff pre-tinned up with some solder on it. Especially when your tip's dirty like this one. I didn't think to have a rag here to wipe it with. I'm putting some pre-tinning the solder on my resistor, and I'm going to try to hold all of this with my hand and the soldering gun, and maybe even stay in frame of the camera. like so. Let's pretend this resistor. That's what I got going so far. Let's take the wires that were on that LED. The LED was marked, which was nice, plus and minus, and it's even color coded with the red being the plus in this case and the blue being the minus. That's always helpful. And why not use those little mounting holes that are on there? Let's run the LED lead -1 right up to the minus for the chip. I'm going to be soldering this again later, so I'm not too worried when I put the power supply leads on what the solder job looks like right at the moment. Because like I say, I'm going to hit it up again. Maybe even find a rag to wipe the tip of this soldering pencil on at the same time. Who knows? So I put the negative side of the LED to the ground, but the positive side we're going to put to our current limiting resistor that we just put on there, so that we're not pushing the LED so hard. There we go, like so. In the end, I think I'm going to route the two wires just from the way this thing's designed, like that. I'll probably put a drop of super glue there, just so I don't have to worry about those wire connections breaking. Alright, so now we're ready to attach it to our first assembly that I already showed you. Can do it without melting anything with my soldering gun. So basically, as I already explained, I brought my cable up and I made some wires which are color coded and just split it off. You have your plus and your minus on this cable, made up to the red and the brown to 3 different lengths, so I could just hook them all together. So in this case, let's take the plus, we'll connect it to the plus on the 555 where we already pre-tinned everything, just like that. And we'll take the minus, just like that. Then, because of the way this particular thing is cut, I can just stuff it up in there, but before I do that, I might want to adjust the timing of it. We don't know. We're going to find out. So, since I'm sitting right here at my computer, let's just undo this cable and I'll just plug it into the USB port. Okay, so it's blinking. But I do think I would like it to blink a little bit quicker. See if I can find a small enough screwdriver here. Here we go. So turning this counterclockwise, this little teeny trim pot, it will speed it up some. I don't want to speed it up a lot, I just want it different than the others. There, I like that. And like I said, it should slide up in there. Get something to push or pull on it with, one or the other. Come on. Got to get the timer started down in the hole. There we go. See, I don't want to secure all this stuff permanently yet, because this piece hasn't been painted. Normally you would have painted all these parts before you would start installing any of this. And good, there. So, what would it look like if it had tops on it? Well, let's grab a couple of them. Get them kind of in the right order. All right. So you could go in and you could retweak the timing on any of those to get them going the way you really want them to go. Maybe to save a video, we'll talk about these tops. These were 3D printed with colored PLA, translucent plastic, green, red, and yellow, on my A1 Mini. You can kind of see the ridges, but not bad. I could have gone a finer layer height, or if you had a resin printer and you happen to have colored translucent resins, you can do that too. It's just that translucent colored resins are expensive. I didn't want to spend the money, whereas I had some translucent PLA already. These parts print flat on the bed just like that, but you do have to have supports, and I'm getting them right now. I saved them. See these funny looking tree things? I selected tree supports because they're the easiest to remove and clean up. Let's take the green one. This would have been on the bed, just like this part would have been on the bed, and this large grove of trees up there were up inside like that, and it prints, and that adds some support right here to this top. Without it, you would have a mishmash problem. And when it's done, you just reach in and you hit it and it snaps off and you've got your support out very clean and ready to go. You can see I've got the supports for the other twos too, which I don't need to keep now that I've shown them to you. But very easy to print as long as you do put some supports in the middle. You don't have to use tree supports. I simply prefer them on this type of a project because they're so much easier to remove, and they give me the support that I need to do the job. So there you have it. You can find some ultra bright flashlights or lights at the dollar store if you want to save money. If you already have some sort of wall wart power supply charger, or maybe you want to go USB like I did, or maybe you want to run the whole thing on batteries. As you see, you could, in fact, because this is hollowed out, you could put some battery holders down in here and you could run this thing off some Penline batteries or AAAs or whatever you wanted. Depends what you want to do. If you're running on batteries though, you're going to have to put a switch somewhere and kind of leave that up to you. But I think that's it for the wiring. I've showed you what the timer looked like that I used and how low cost it is. The only modification I'm doing to the timer is by adding another larger capacitor to it to slow it down some, and changing the current limiting resistor to the LEDs because I don't need to push them that hard. Maybe you want to push yours that hard. Leave the 1 ohm resistor in there that came in the kit, and these things will really light up, and you'll eventually burn out your LEDs too. But that's up to you.